And we're going to go ahead and look at the problems on this next page. So it says factor each of the polynomials completely. So for A, we have 5x squared minus 80. So again, the first thing we want to do is look to see if there is a common factor. So common factor, yeah, we can take out a 5. And when we take out a 5 times what is going to get us negative 80? That's negative 16. The second step is to look to see if there is a difference of squares or a perfect square trinomial. And since this has two terms, we're looking to see if it's a difference of squares. This is subtracting, so that is a difference. And the first and the last term, both of those terms are perfect squares, so that's a yes. So we can write this as x plus 4 times x minus 4. And again, that's because the inner and the outer terms cancel each other out. You can only do it like this if it is a difference of squares. So this is factored. For part B, there's no common term, so you could try 3, but 3 doesn't go into 35. So next thing to do is look to see if it's a perfect square trinomial, and this is a perfect square, so A would be 3x. B would be, well, it's not a perfect square, it's 35. So because it's not a perfect square, we go ahead and do our last option, which is just factoring it normally. So we need two numbers that multiply to whatever the first term times the last term is. So negative 35 times 9. So that would be, what's that, 315? So we need two numbers that multiply to negative 315 and add to negative 6. So this one could take a bit of time. So we need two numbers that are off by each other, or off from each other by about 6 units. So let's try a few. Does 15 go into 315? So if you do 315 divided by 15, we get, oh, that happened to be it. I was hoping not to get it on the first time, because then I can't show you the whole process of trying out numbers, but anyway, okay, so 15, I keep hitting the eraser. 15 and 21 go into 315, and one of these needs to be negative. If we make the 15 negative, then they would add to positive 6, which means that we need it to be the 21 that's negative. So that's 9x squared, and then we're replacing the middle term with positive 15x, negative 21x. And then notice I just put a 6 there. That 6 is wrong. That should be minus 35, because we're rewriting the original polynomial. So we want to have that first term, the last term, and then we just replace the middle term with two separate terms. And whether you put the 15x or the negative 21x first doesn't make a difference. So now we group them together and look for common factors. We can take out 3x. So we have 3x plus 5. Take out a negative 7. So we have 3x plus 5. They both have 3x plus 5, so that's 3x plus 5 times 3x minus 7. Okay, go ahead and pause the video and do the try this problem. Again, make sure that you look for the common factor first. Look to see if there's difference of squares or perfect square trinomial. And then if none of that is the case, then you factor it normally. Okay, now that you've done that problem, we're looking at number 4. It's solving equations when we have what's called repeated factors. So that means the same factor more than one time. This is the same thing as what we just did from 1.9. So the same factor. So perfect square trinomial means that you're getting the same thing twice. I think I tried to say that too fast. But we're going to be solving it now, which means when you solve it, we're actually looking for a value that makes the equation true. So to solve, we need to set everything equal to 0 first, and we can do that by adding 64 to both sides. And there's no common factor that goes into all three of these numbers. If you tried 3, it wouldn't work for the 64. So there's no common factors. So now we want to check to see if it's a perfect square trinomial. And It's going to be, but let's just double check that. So the square root of the first term is 3x. The square root of the last term is 8. We want to check to see if the middle term is, and because it's negative, we want to see if it's negative 2 times a times b. So is it negative 48x? And that's a yes. So because it's a yes, we can go ahead and factor it as a minus b times a minus b. And it's a minus b times a minus b because that middle term is negative. So that's going to be 3x minus 8 times 3x minus 8. And this is equal to 0. So again, we're solving this one. So if 3x minus 8 times 3x minus 8 equals 0, then we can set each of them equal to 0. So then we add 8 to both sides. 3x equals 8, divide by 3. We get x equals 8 over 3. So this is a solution. And then if you do the same thing again, you're going to also get x equals 8 over 3. So it's the same solution twice. You don't need to write the same solution twice. As soon as you see that it's this quantity times itself, you can just do it one time. And that's going to lead into this last concept called the square root property, which before you do the third try this, I actually want to just touch on that real quick. So if you notice, when we did the 3x minus 8 times 3x minus 8 equals 0, that's the same thing as 3x minus 8 squared. And this leads into what we call the square root property, which says that if you have a quantity squared, so x squared equal to a number, then you can take the square root of both sides and get two separate solutions. So if we took the square root of this side, then we get 3x minus 8 equals, well, square root of 0 is just 0. So then in that case, we would also have gotten the same solution, x equals 8 over 3, and that was the only solution. Okay, so that was a quick tangent to what we were going over last, so go ahead and pause the video, do the third try this problem. Okay, so last concept, again, back to the square root property. So if you have x squared is equal to n, then we get that x equals plus or minus the square root of n. So plus or minus, that means the positive version of the number and the negative version. And that's because either of those would make the equation true. So for example, we have a square root on the left side, so we can take the square root of both sides. When you take the square root of the left side, we just get x. But the square root of 25 is positive 5 and negative 5. And you can check that. So if we plugged in positive 5 squared, that's 25. Negative 5 squared, well, negative 5 times negative 5 is also positive 25. So there's two solutions here. The reason why this previous one only had the one solution is because it was equal to 0. So the square root was equal to 0 on its own. Okay, so for number 5a, it says solve the equation and check your solutions. So we're going to check them to make sure that they work with our square root. So before you can use the square root property, you first need to get the quantity by itself on one side. So what I mean by this, all of these are written out so that you can just take the square root from the start. But if this was instead written as like y minus 6 squared minus 81 equals 0, then you could move the 81 over, so then that way you can take the square root of both sides. You cannot take the square root of both sides unless you only have a quantity by itself squared. Otherwise you cannot do it, so I could not just go and take the square root of that. Hopefully that makes sense. So it's the same concept as like, I don't want to see you guys taking the square root of a problem like number 4. You're only taking the square root if you have a quantity, whatever that quantity is, squared. Everything else has to be on the other side. Okay, so hopefully that made sense. We'll go over that on Tuesday's more. So we can take the square root of both sides, and the square root cancels out the square. So we're left with y minus 6 equals, make sure you do both solutions. So that's plus or minus 9. So the next thing that we do is get y by itself by adding it to both sides. And I like to add it in front of the plus or minus term so that we get 6 plus or minus 9. That way we can do 6 plus 9, which is 15, and we can do 6 minus 9, which is negative 3. If you did it where you added the 6 and you put it after the 9, that's okay, but you need to make sure to do positive 9 plus 6 and negative 9 plus 6. And you'd still get those same solutions. So we have two solutions that make this equation true. And now we need to check them. So check them both to make sure that they work. So to check them, we plug them back into the original equation. So if we plug in 15, that's 15 minus 6 squared equals 81. 9 squared equals 81. Yes, that's true. And then we check y is equal to negative 3. So negative 3 minus 6 equals 81, and that's squared. Negative 9 squared equals 81. And negative times a negative is a positive. So positive 81 equals positive 81. So they both work. All right, part B, we have the same setup. So this is a quantity. The whole quantity is squared. That's the reason why we can take the square root. So we can square root both sides. We get x plus 6 equals, and remember it's plus or minus. And the square root of 12, well, we don't know what the square root of 12 is. So what we want to do is try to simplify that. But first I'm going to just put plus or minus square root of 12. So you can simplify that by looking to see what the factors are. 2 times 6, 2 times 3. There's a pair of 2's, so I can take out a 2. This is what I've got. If that doesn't make sense to you, you can always write it as a decimal. So you could do plus or minus and then whatever the square root of 12 is, and then use that number. And then again, next step is to get x by itself. So I'm going to subtract 6 from both sides. And I think it's easier if you put that number in the front of the plus or minus. And so we have two solutions here. And if they come out to be whole numbers, so in number 5, part A, they both came out to whole numbers, integers, then you need to write what those are. But in this case, because these are not going to be integers, we have the square root of 3 in there, you can just leave your answer like this, negative 6 plus or minus 2 times the square root of 3. You could write it as negative 6 plus 2 rad 3 and negative 6 minus 2 rad 3, but there's no need to do that because the plus or minus already means that for you. But again, if you got like x equals 1 plus or minus 2, well, those are integers, so you've got to keep going. You need to do 1 plus 2 and say it's 3, 1 minus 2 and say that's negative 1. Okay, you've got one problem left. Try this number 4, so go ahead and give that one a shot.